Today we will be discussing a better way to move forward with the Bechta dump site. This slide aims to provide a brief background about the project. Presently, the Bechta dump site has served the needs of the urban population nearby for over 40 years. However, throughout this time, the conditions have been getting worse, especially with fires and much of the waste going unregulated. This is posing to be a huge safety hazard given its proximity to nearby residential areas, an orphanage, and even a women's medical clinic. The Warrior solution is to close and repurpose the Bechta dump site to prevent further contamination of the environment and to eliminate fire and disease risks. Next, we have created a well-thought-out design for a new manageable sanitary landfill with plans for incremental expansion. The agenda for this presentation consists of plans for closing the old site, a well-thought-out analysis of construction of a new site, cost analysis, timeline for construction of the new site, and conclusion and recommendations.
The following section will describe the proposed closure process of the Bechta dump site and why the project is important to complete. The Bechta dump site borders a residential area, a women's clinic, and the Gambia's only orphanage. Smoke and groundwater contamination have made life difficult for residents, but Warrior Consulting has created a plan that will end or greatly reduce the dump site's impact while keeping in mind the limited resources available. There are several steps that should be taken before closing the dump site to promote the safety of Bechta residents. To keep people away from the dangerous machinery in the hazardous site, Warrior Consulting recommends the KMC communicate the closure plan to customers and neighbors of the site and continue using local police to regulate access.
The protected walkways and pedestrian bridges across Kotu Highway will protect children, employees, and general users as they cross the Bechta site. And as of February 24th, the SOS Children's Village, in partnership with the KMC and German BMC, have developed a waste management scheme designed to reduce child rights violations at the Bechta dump site. The ISWA scholarship program may also be tapped to provide alternatives for the children at the site. And in addition to children, there are somewhere between 100 and 300 people currently serving as the municipality's informal MRF. And since they have already expressed interest in a controlled, safe environment, Warrior Consulting recommends that this group be trained to run the new transfer station and material recovery facility.
Closing the Bechta dump site will be a complex process of excavation and air and water management, but it will promote local industry and improve safety and quality of life for those near the dump site. Warrior Consulting proposes a plan to excavate the dump site as opposed to capping it in place. We believe that the benefits of removing contamination and freeing up real estate in a densely populated and quickly growing area like Bechta will be worth the cost. Excavating will further limit groundwater contamination from the dump site and accommodate new land uses like farming developments, as well as provide a location for the transfer station/material recovery facility. The zones of the site will be excavated in alphanumerical order as shown, with the northwest zone of Zone 3 being excavated last.
The ACPC will be the first large-scale field application of granular activated carbon in a landfill cover system. The research from Siddhasavam and Reddy showed the increase in oxidizing capacity of landfill cover soils through the addition of GAC. This additive to the temporary cover is a passive gas control measure requiring no maintenance and which will work in wet weather. There is a high potential for outsourcing the cost of the GAC through PPPs or other investment. The inclusion of native grasses such as vetiver in the top layer will aid in mitigating erosion and stormwater infiltration.
An interim drainage and gas management system shall be constructed on the cap to serve during excavation. Afterwards, a similar stormwater system shall be constructed, and the vent flares shall be relocated to the new site. If the dump site mining cannot be completed, the initial system will serve as the long-term management solution. According to the US EPA's WARM model, installing a vent flare system will more than halve the CO2 equivalent released, and using the quad stream waste diversion system will result in nearly zero net emissions from new waste. Nearby residential wells will be used with the owner's permission to gather groundwater data. It is hoped that the Gambia's Water Quality Lab in Ibuko will analyze the samples immediately or be able to expand its capabilities for leachate testing soon.
As previously mentioned, the primary driver behind excavation versus cap-in-place closure is the value in developing a site of this size and location. Development recommendations were made from a nexus of industrial, financial, residential, and ecological considerations. The Warrior Consulting solution proposes developing the site by zone, providing immediate relief to the dump site conditions and facilitating gradual improvements as funding is made available. The final state of Zone 1 will include the protected pedestrian walkway, the transfer station and material recovery facility, employee housing, and the opportunity to continue the existing waste education programs. The transfer station material recovery facility design meets the KMC's waste processing needs with a low-tech design that minimizes O&M and the need for specialized mechanical equipment. The building follows EPA guidance to top-load transfer stations and is sized to accommodate a worst-case scenario where all generated waste would need to be processed by the TS-MRF before being sent to the landfill. This size is estimated to serve the KMC through 2050. The facility itself is a slab foundation to minimize differential settlement that may occur in the backfilled material. The building structure is a prefabricated aluminum truss and ripstop nylon cover from Clearspan. This structure minimizes construction time and maintenance costs while maximizing airflow and natural light. With the average daylight hours in the Gambia matching or exceeding the working hours, this will minimize the need for additional electrical lighting. The airflow is both critical at the moment for COVID precautions, as well as in general for the hot and humid Gambian climate. The low-tech MRF is designed to push the source-separated recoverable materials through channels protecting the MRF employees, from which they can pick out and sort valuable materials. These materials will then be processed on-site and collected by local merchants. The materials collected include LDPE and HDPE, 20-gallon HDPE jugs, textiles, ferrous materials, and aluminum. The new material flow diagram details the best-case scenario management system with present-day tonnages. Currently, 26% of waste is burned by residents at home. With the KMC's push to reduce burning, the larger size of the transfer station will be sufficient to handle the additional municipal waste. Lastly, to avoid displacing the people who currently reside within the Bakutu boundaries and to provide safer and more sanitary living conditions, simple employee housing shall be constructed in Zone 1. The residential block will be separated from the facility by distance, a soil berm, and vegetation. And as they know the residents best, the KMC shall be responsible for facilitating this relocation.
There are several proposed developments for Zone 2 after closure. The protected walkway running between the zones will be maintained after closure as a durable surface for foot traffic. Water treatments and a fountain may be used to reduce mosquito larvae in the pond. The border of Zone 2 will be planted with deep-rooting trees and grasses to provide a better barrier between excavation activity. An apiary co-op will be founded to promote new plantings across the site and provide economic opportunity for participants. Zone 3 may be used as a location to expand the apiary and will be planted with native landscaping similarly to Zone 1. It will also provide a new area for residents to plant crops. A table showing a breakdown of the closure costs is pictured. The excavation costs were scaled from the KMC's current contract with the large bulldozer at 50,000 Dalasi a day, and the solar flare costs were based off an EPA guide to vent flares. The transfer station/material recovery facility represents a good donation opportunity for an international organization or firm, and it is hoped that one will be interested in donating the structure. Once constructed, the system is expected to be self-sustaining with revenue from recoverables.
Hello, my name is Brianna, and Dimitri Amroth and I will be walking you through the development of the new landfill site today. To begin the siting for the new landfill site, we first looked at the area surrounding the current dump site, which consisted of shopping malls, small businesses such as restaurants, and residential areas. So we knew that area in particular wouldn't work. There is a lot of municipalities all around the dump site, so we continued scouting south until approximately 25 kilometers south of the dump site until we found a designated area that would work for the new landfill site. The new area for the landfill site is currently occupied by farmland for the most part and a select few farmhouses, so appropriate contracts and agreements would have to take place between the KMC and these landowners. While siting for this landfill area, we paid close attention to surrounding airports or residential areas, commercial areas. We paid close attention to this while referring back to ISWA's guidelines and often referenced EPA's Subtitle D standards. While siting for the new landfill, transfer routes for the trucks were paid close attention to as well. The fastest route is approximately 55 minutes long and 23 kilometers in length. That image is shown on the left, and on the right you can see the last couple turns that the trucks would be taking to get into the landfill. Another important thing about this landfill siting is that it could be accessible to multiple municipalities in the future, which would provide a wider solution to the Gambia.
Hello everyone, my name is Dimitri. I'm going to start by talking about the sizing of the new site. The main thing is that we designed this to be a regional landfill, meaning it can accept waste from the surrounding area. And we chose this because of land availability, meaning there's not very many open spaces suitable for landfills, and because of long-term sustainability. There's a lot of other cities in the area, and they're all going to be facing solid waste problems into the future. We want to mitigate the potential use of open dump sites, and creating one centralized landfill would be the best solution. By involving the KMC in a regional project, we're able to secure more funding for equipment and machinery. The waste volumes were calculated by the expected production rates with the compacted densities over a 20-year period for the greater area. The landfill volume and the area are also made to include the fill material as well as the slope. The landfill was designed for a worst-case scenario of 0% waste diversion, meaning that if no recyclables or compost were taken out, the landfill would still be okay. The limitations that we worked under were in excavation and machinery, that we weren't able to go very deep or build very high due to lack of equipment. Now I will discuss the fluid management plan of our new landfill. Leachate and landfill gas will be managed with a passive system due to the lack of infrastructure and the costs and complications of installing and maintaining a more intensive system. Our fluid management plan starts with a vertical communication system that will link the bottom liner to the top of the landfill through high permeable pathways using gabion cubes and perforated piping. This will help drain the fluids to the landfill. The landfill gas will then be combusted using a solar flare. The leachate will be pumped up from the bottom liner and into a constructed wetland using a wind-powered pump. Here you can see a cross-section of the landfill as seen looking from the wetland area. The bottom of the vertical communication system would be on the top of the drainage layer, and this will allow the leachate to drain into the collection mains. As the waste mass increases, it is important to extend the vertical communication system as well as lay down horizontal piping to help create a matrix of permeable pathways that will drain the fluids. The landfill gas will be allowed to vent upwards, and then the leachate will drain downwards through gravity. Once the system is complete, we can implement a solar flare that will be able to thermally combust the landfill gas. Here we can see the other cross-section of the landfill, looking at both the landfill and the wetland area. The drainage layer will be sloped in order to collect leachate on one side, where a wind-powered pump can be used to pump the leachate up and into the wetland area for treatment. So here we can see a plan view of the engineered wetland. Starting from the right, the landfill leachate will enter into a forebay. Similar to stormwater design, the solids can have a chance to settle out, and the required dredging area is much smaller. The forebay will be separated from the wetland by a flow-over berm. This berm will be designed to retain water, but also overtop in case its capacity has been reached. We also have the option to input a pH adjusting barrier that can be replaced into the berm. This barrier can make the liquid more hospitable for the wetland plants. Now, in the wetland area, this is where the remediation and the evaporation will take place. Once the wetland's capacity has been reached because of weather or new cells have been constructed, the current wetland can be adjoined to another wetland to expand the surface area and to reduce the amount of dredging. Of course, the wetland border should be fenced and, if possible, bordered by a row of trees to promote safety. And now I'd like to talk about education and training. This is an integral part of the long-term sustainability of our solution. It is necessary not only to educate the public, but also to train skilled technicians in order to keep these systems working in the future. The closure of the old site and the construction of the new site will serve as training opportunities to create a local workforce and create jobs in solid waste management. The KMC and the Gambia will ideally partner with companies, and universities to help provide expertise and training, with a focus on organizations within the continent to help create a network of solid waste management.
Once the landfill has reached its capacity, a final closure plan will then be implemented. A single geocomposite liner covered by geomembrane and compacted soil will be used to keep rain from entering the waste and producing leachate. In addition, we will be adding topsoil on top of the liner system to protect the integrity of the liner. The soil can then be vegetated with grasses and shrubs for stability. Since the final grading of the landfill is not steep, there is also potential use for grazing and livestock.
The new landfill is anticipated to be funded by the national government, multiple municipalities, KMC, and other international organizations. The chart here on the right is a cost estimate for one single cell for the landfill, which is about $22.1 million. The landfill can hold a total of 8 cells, which has an approximate lifespan of 20 years. That's 2.5 years a cell. So if you times the 22.1 million times 8, you'll get the total cost for the full landfill after 20 years.
The Warrior Consulting Solution Timeline integrates construction with training and education to build local capacity in solid waste management. The integration of the closure and new construction timelines prioritizes an expedient solution to dump site conditions in combination with capacity building. The incremental closure and construction plans are designed for the initial segments to serve as training opportunities, empowering the domestic waste management industry to continue the work without international intervention in the future. This approach also alleviates the need for financing the project as a lump sum, providing time to integrate the involvement of neighboring municipalities and to secure funding from a multitude of sources. The new landfill construction process will begin with the site survey in January 2022. Construction time was estimated using a 6-day work week and a 10-hour work day consisting of 2 shifts, which aligns with the current schedule for the Imbalit Waste Management Operations Team. On this schedule, the new landfill is set to begin receiving waste in August 2022. Closure is scheduled to begin in August 2021, with timing to open in mid-May 2022. This is 6 months prior to waste acceptance at the new landfill, when it begins the following August, to allow for training and education on the new system. The excavation of zones 2 and 3 is provided as if funding were immediately available. This time estimate is subject to delay, pending delays in funds acquisition.
And now I'd like to go over our conclusions and recommendations for how to best move forward with the dump site and the new landfill. For the closure of the old site, we recommend that in order to ensure public safety, improve public health, ensure safe development, and reduce long-term costs with monitoring, that the source of contamination be removed. By using passive systems for stormwater and landfill gas control as temporary or permanent solutions, we can mitigate many of the health risks associated with the dump site. The closure of the dump site should create jobs, improve outcomes for children and waste pickers, and create an alternative structure of waste management in the area. For the new site, we recommend that it be sized to meet regional demands. This is because it can secure more funding, make best use of land availability in the country, and provide a more sustainable solution in the long term. For fluid management in the new site, we recommend that passive systems are used, such as vertical communication, solar flares, wind-powered pumps, and a wetland for leachate treatment. This will reduce the cost and maintenance of any new infrastructure. In addition to any infrastructure, we recommend that it is vitally important to focus on education and training. By training the next generation of workers and educating the public on solid waste management, our solution can be sustainable long into the future. In conclusion, our proposed solution will achieve the following: close the Becca dump site while benefiting the economy and improving environmental and public health. Incrementally construct a new sanitary landfill to serve the KMC and the greater region as needed. Build capacity in the country for independent operation of solid waste management. And to position Gambia as a leader in dump site closure. Thank you all for listening. Now I'd like to open it up for our team to take any questions or comments.
Thank you very much, Warrior Consulting Group. Excellent presentation. I will now open it up for questions from the judges. We have approximately 10 minutes.
All right, I'll start. Thank you so much, Warrior Solution, your team, for coming up with this presentation, your report, your efforts on everything. Really thought you had a great connection to the problem and the people in the intro to the presentation. Really liked aspects related to the MRF and transfer station design and location of that. One question I have, when excavating out the dump site, there's some excavation activities happening prior to the timeline of the new sanitary landfill being built. Where would you plan to put that waste in the interim time before the new sanitary landfill is constructed?
Chris, thank you for the kind words. And we did anticipate that question because that was an oversight on our part when we were building the schedule. The idea, our part being my part, the plan would be to begin the excavation of Zone 1 after the construction of Cell 1 so that there is a place for the waste to be transferred to, and then have a 6-month gap between the construction of the transfer station before it opens for business.
Okay, I'll go next. Also want to thank you all for such an outstanding presentation. It definitely shows that you've done a significant amount of work. Really appreciate it. And as some of you might guess, I'm from Gambia, so this is a project that's very close to my heart. Even though I live in the US, my family and lots of my friends still live there, and I always do go visit. So it's definitely a problem that's very close to my heart. Question for you guys and your team is the logistics of moving, excavating, and backfilling. You gave a patented option of backfilling. You also talked about excavation, but when you look at the roads, you also estimated that the distance is about 23 kilometers and takes about 55 minutes one way. The challenge, to make it a little challenging back home, is there's not plenty of road options. As you've seen, we've shown 2 options. And those are what pretty much the whole traffic system relies on. So when you have such an excavation process that includes a lot of waste on a regular basis, with the smell traveling over 55 minutes, how do you guys expect to deal with that, with logistics of traffic jam and other things?
Sure. Yeah, that is definitely information that I think if we were in a real life scenario, that would have been the traffic complications would have been something we would like to have requested from the client. Would definitely be a traffic study that we would have to do to make sure that that is possible, and could use some adjustment with either smaller vehicles or adjusting the timeline with that information if we had it.
I'd like to just add on to that one. I had a question that builds on that. You know, your one of the biggest things within your proposal. Well, actually, let me back up first. And first, I just want to say you guys did a really excellent job. You did a great job finding additional information that wasn't always in some of the other reports. I liked how your design tried its best to incorporate low technology, low maintenance items with solar flares, etc. I think that's going to be critical in this application. And I really like the use of the trommel screen to sort soil and try to reduce volume that way. Building on Kaba's questions, one of the biggest, I'd say, components of your design is to excavate all the old waste and haul it almost an hour away, and then bring spoils back from that site to fill in and reclaim that site. So how would you say, as you evaluated that, how does that weigh out? You know, excavating, cost, potential odors, etc. Where do you see the benefits of that compared to if you had left the waste in place and tried to mitigate the groundwater issues and just cap that site?
Yeah, so we'd go with excavating it as opposed to capping it in place. Largely that was because it's in such a high populated area. A lot of dwellings around the back to dump site. It's an expanding area with an increasing population that's looking for more real estate to build into. So that was another reason where we thought we could use that area for more productive purposes than just capping it. It's never really a trustable surface. We did factor in the trucking costs to our excavation expenditures. where we would have, I think, 22 dump trucks running for the one excavator. So that was factored into the price, but as far as the smell goes, it's going to have to be, for our plan, a temporary grievance that'll hopefully lead to a longer term, better area.
Yeah, thank you for that explanation. I think too, at least in my math, I was doing it very quickly, but we might need more trucks too. If you have a 55 minute haul distance with 10 hours a day, there's only so many trips each truck can make. So I think you might need almost double that many trucks, if my math was right.
Okay.
Just wanted to add a few things that even if it turns out to be that excavation is not the optimal method, it is you guys have definitely demonstrated some real thought into this process, and I think that's what we're looking for, to really understand the dynamics. And though you haven't been to the ground, it's also sound like John said that you've definitely done some research, and so we truly do appreciate that. Even when Chris and I were there, we thought about excavation as an option. I think we were more leaning towards capping as is where it is instead of excavating. But nonetheless, yeah, that was the thought at the time, but I would still revisit and think about it a little bit more. Just one thing, there was a comment that I wanted to make just for clarification. There are more than one orphanage in the country. This one happens to be the biggest. But there are definitely more than one in the country.
Okay, thank you. Thank you for that correction. I think we read that in a paper somewhere, so maybe the paper was older and there's new things, or yeah, thank you for the correction. Appreciate it.
Good morning and good afternoon from Gambia and morning in US. My question is, I think Chris has buttressed on my question, and that is the excavation, because I think 1 month ago we experiment an excavation at the site. And unfortunately for us, in Gambia, there's no segregation of waste. All the waste are dumped at the back of the dump site at the final, disposal site. That being the case, when we actually excavate, we don't have any clean soil that could be reused at the dump site for fire preventions and all the other stuff. So actually, it's going to be very much challenging to have even a clean sand from the back of the dump site, putting into consideration that there is no waste segregation. I will not call it proper, but there is no waste segregation at household level. That's going to be a very good challenge. And the other thing is the transfer station that has been made mention of. It's very much critical, looking at the distance that the dump site that have been identified, not yet officially given to us, the 3 urban municipality. But we hope, we are in the process of trying to get, finalization from our land ministry to be able to use that site as a landfill. Though we are working on 3 areas different from the one, because when I looked at the map itself, it was, I think, when Kaba and Chris came, the first idea was, around Jambanjeli. That's where I think the team have captured. But presently, we are told that might not be definitely ideal. The ideal place could be around Faraba, Jenikunda, and Dimbaya. That's what we are trying to work on to conduct a feasibility study. So I would like the transfer station, when I looked at it critically, by your plan, is it really, what are the materials needed for the transfer plant?
Thank you. The transfer station is just a slab, so a reinforced concrete slab. And the clear span structure for the walls and the ceiling will be prefabricated and can be constructed. I did speak with someone at Clearspan, and they didn't have a precise, they haven't ever done an international installation of their product. So we're entirely sure, and it's not set on being a Clearspan product, but they were saying that they could get that up, in a matter of weeks, rather than doing a full, like a brick construction of a building that could take up to a year or more. So that those will ideally, besides with the excavation of the foundation being concurrent with the backfill after the waste excavation, those would be the three components. So forming the excavation, pouring the slabs, and installing the overarching structure.
Right, thank you. I was joined the other judges. Actually, I was really, really impressed to see the kind of work you guys have done. Definitely, it shows that you have a concern and that you have dig further in order to get valuable information to be able to compete in these competitions. I was really surprised when I see some of the ideas and the information, that you guys brought together to be able to, compete. I really thank you for that job. Well done. Keep it up.
Thank you. And thank you for being here. We really appreciate the personal knowledge as well.